Hello, ladies and gentlemen, and welcome to AP Statistics. I am Mr. Bowman. Myself and Ms. Harding will be teaching the 4 sections of this course this year, and I'm going to start out with a little bit of explanation about the course, and then we're going to get right into an activity. For this course, we will be using the 6th edition of the Practice of Statistics. You can have either an online version for it, or of it, or a hard copy of it. The homework problems that we will be assigning, though you will be submitting those electronically through Canvas, will be in both the electronic version and the hard copy version. During a normal year, we would be covering all 12 chapters of this textbook. Last year, the College Board decided to cut the last 2 chapters from the AP exam, and we're still awaiting word for what their plans are for this year. So what we're going to do is we're going to proceed as if we're going to cover all 12 chapters, and if things change, we will let you know. So since we're going to start right away with an activity, a lesson, so to speak, you are going to need to make sure that you have a copy of this textbook so that you can get going on the homework problems. There aren't any homework problems from the textbook associated with this first assignment, but there will be shortly. The next thing I'd like to do is lay out for you kind of the topics that we will be covering. So I'm going to move over here to the College Board website and show you what the breakdown for at least the multiple choice portion of the AP exam would be during a normal year. And we have these 9 units, and you can see what the exam weighting is, and that's about what it's going to be for the free response also. So these units are units that are created by the College Board. They don't necessarily correspond to the chapter numbers in our textbook. For example, Unit 3 is on collecting data. That corresponds to Chapter 4 of our textbook, and even though that shows up as the 3rd unit for the College Board, we're going to start with it because basically what we are going to talk about in this course is collecting data, interpreting data both numerically and graphically, random variables and probabilities, sampling distributions, and then we get into inference, which at the moment, some of this stuff may not make any sense to you, but it will as we move along through the course. So without any further ado, I'd like to move on to the first of many activities that we will be working through during this course, and those will be posted for you on OneNote. Normally, and by that I mean during a normal school year, you would have copies of these on OneNote, and you and your classmates would read through them, answer the questions, do the activities, and hopefully walk away at the end of a class period with a pretty good understanding of the content associated with that activity. This year, Ms. Harding and I are going to work through these activities for you. We are going to be skipping some of the content, the stuff. We're going to focus on what we think are the core of the course. But if at any time you want to go back to these activities, they will be there for you. And if you would like, you can scroll down to the second half of these, and basically it looks like the same activity, but it's with our written solutions to them. So if, for example, you wanted to go back and reinforce some of the concepts that were covered during our video lesson, you could do that. So here we go. Chapter 4, again, is on collecting data. And in section 4.1, we're going to talk about, one of the things that we're going to talk about is collecting data using a sample. And a sample is simply a subset or a portion of the population that we are interested in knowing something about. The population is the entire group, the whole group we want information about. And sometimes you can collect data from the entire population, at least in theory. You might have heard the word census before. It's actually going on right now. And the idea behind a census is to collect information from the entire population. Well, that's not always possible. And as an example, let's say that I wanted to know the makeup of all the fish in the Great Lakes. Well, there's really no way of knowing that for sure unless you had the ability to somehow scan or drain the Great Lakes and do an accounting of all the fish in the Great Lakes. So in lieu of that, what we want to do is we want to take samples, smaller portions of the population that are representative of the population, and then use those to make inferences, make conjectures, make educated guesses about the makeup of the population. When we collect those samples, one of the things we have to work very, very hard to avoid is bias in our selection process. And bias simply means that by using a particular method of selection, we are consistently or regularly overestimating or underestimating the measure of the population that we are interested in. So one of the things that you might think is that if we took something like fish in the Great Lakes, how probably uncontroversial that is, or non-controversial that is, that you could just let a knowledgeable person go out and select a sample of those fish and then use the makeup of that sample to make inferences about the population. Well, unfortunately, that's not the case. And so what I'd like you to do right now is pause the video for a moment and think about question number 1 right here. We will come back and address those questions a little bit later on, but first I want to try and convince everyone that it's really, really hard for someone to pick a sample without there being some sort of bias. So I'm going to do that with an example. And this example is the following. At the end of the activity, there are 100 random rectangles numbered from 01 to 00. And each of them has an area associated with them. So one of these rectangles right here is 1 square unit. So for example, number 6 is 5. Number 6 right here is 5 square units. So what I'm going to do, what I'd like you to do, is pick 5 that you think are representative of all 100 and then calculate the average area of those. So I'm going to scroll back up here to the top, and in this table you're going to enter the rectangle number, the area of that rectangle, and then you're going to calculate the average. I will pause that for right now, pause the video for right now, and give you a moment to do that. All right, so I picked rectangle numbers 17, 22, 49, 55, and 90 as 5 rectangles that I thought were representative of all 100. And their areas below, 9, 12, 10, 16, and 16 respectively, came out to an average area of 12.6. Now, what we would normally do is I would collect that data and plot each of your averages to look and see if collectively as a group your estimates or your samples were unbiased or not. I'm going to show you how they were in a moment, but before we do that, what I would like you to do is I would like you to do this simple experiment right here. I would like you to pick one of the numbers 1, 2, 3, or 4. So if I had to guess which number you picked, I would guess number 3. If we were picking without bias, in a large group of people, each of the numbers 1, 2, 3, and 4 would be picked about 25% of the time. But it turns out that when we do this experiment repeatedly, about 75% of the population, or the subjects that take part in this experiment, actually picked number 3. What number did you pick? If you picked number 3, you're in good company. So what I want to do now is show you one of 2 methods that we are going to use to randomly select subjects or collect data for situations like this. And this is going to require our calculator and a built-in function called the randint function. So if you need to, pause the video for a moment, grab your calculator or load up your calculator on your Chromebook, and then we will proceed. So here we are on the home screen of our calculator, and our calculator basically has what's called a random digit table in it. And the digits are the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And what we can do is we can get our calculator to select random digits for us, or combinations of random digits for us. But before we do that, we need to tell the calculator somewhere to start. And we don't want everybody to start at the same place, otherwise it's not really random. So to get the calculator to start at different locations in this random digit table that it contains, we're going to do what's called seeding the calculator, basically telling it where to start. So what you should do to seed the calculator is pick a 4-digit number, not the one that I pick, but pick a 4-digit number. So I'm going to pick 1, 2, 3, 4. Then you're going to hit the store button, which is right above the on button. And then you're going to hit the math button, which is right below the alpha key. And then you're going to go over to the probability menu and select item number 1, rand. This process doesn't have to make any sense to you. It's only something that you have to do after your calculator has been reset. So you pick your own 4-digit number, hit the store key, select rand, and hit enter. And now we can proceed with generating random integers. You may have an older calculator, so be patient because I will explain what the format looks like if you have an older calculator. So the next thing we want to do is we want our calculator to select for us 5 random integers in the range from 01 to 100. And we're going to use those to be our random sample of our 100 rectangles. The way we do that is the following. We hit the math button, we go back over to prob, and select randint, which is number 5. Again, if you have an older calculator, be patient. I will explain what the command structure looks like. Lower is the lowest number that you want the calculator to generate for us. So we're going to use 1 there. If you don't have a 1, type in a 1. Upper is 100. If you look at the table of random rectangles, or the page of random rectangles, it goes from 01 to 00. So we're going to treat 00 as 100. So that's the upper limit that our calculator is going to generate. And then how many we want to select at a time. I recommend leaving this set at 1 because if you are generating random integers in the range from 1 to 100, and let's say the number 7 shows up twice, you're not going to use rectangle number 7 2 times. You're going to pick another rectangle. So when we say a sample of size 5, we mean 5 different subjects in our sample. And then you scroll down and you hit the paste button. Okay, for those of you who have an older calculator, this is the format that you're going to type this command in. When you hit the randint button, it's going to come up blank with a left parenthesis. You're going to put the lower number in, comma, the upper number, comma, how many you want it to generate. So then you hit enter and it generates for you a random integer. So what I'd like you to do right now is pause the video and generate 5 unique random integers and put those numbers in this table, the next table here, write down their areas, and then calculate the average area. So the 5 rectangles that my calculator randomly selected were rectangles 3, 19, 10, 38, and 80, which had areas of 1, 1, 1, 9, and 2, and that gave me an average of 2.8. You will notice that that is distinctly different from the average that I got when I picked the 5 rectangles on my own. At this point during a normal class, what we would do is we would have all of you come up and enter the data into a program that is going to display a graphical representation for us. But since we can't do that, we are going to use some data that we already have from previous years. It consists of about 250 students who have done this, and then we're going to discuss that. So here's the data that we have collected over the years. There are 3 columns showing. We're actually going to ignore the first column and look at the last 2 because that's the way that we actually collected the data in this video today. So the middle column says subjective, and that was basically us trying to pick 5 rectangles that we thought were representative of all 100 rectangles and then calculate the average area. And then the last column, SRS, stands for simple random sample of all of them. And you will notice that they all have both columns have a range from some relatively low numbers to some relatively high numbers. You might also notice, though, that the subjective column tends to have more of the larger numbers, like 10.4, 11.6, and so on. So it's really hard to visualize data in a table like this, so we're going to jump up to the top and we're going to look at what are called dot plots. These are 2 dot plots, and each dot on here, let me click on one of these, we'll make it red. So that red dot there represents one average of 5 rectangles selected by one student. And so you can kind of see how they're spread out. And they're both put on the same scale for easy comparison. Within those dot plots, you will see 2 vertical line segments. The brown line segment is the actual average of 7.4 for all 100 rectangles. The blue line is the average of the averages, yes, the average of the averages of all of the data that we've collected over time. So what you can see with the subjective approach is that the average of the averages tends to be notably higher than the true average from the population. The average of the averages turns out to be about 9, and the true average is about 7.4. Another way to look at this is to see that about 2/3 of the averages selected over time, maybe 2/3 to 3/4 of them, are higher than the actual average. This is what is meant by bias. The method that was used consistently or regularly overestimates the true population value of 7.4. Now, on the other hand, when we used a random selection, you will see that the 2 lines, the average of the averages and the average of the population, are very close. And that also is illustrated by the fact that about half of the dots in the dot plot are above the true average and about half of them are below the true average. And that's an example of an unbiased method of selecting a sample. So hopefully this activity has convinced you that we are incapable of selecting unbiased samples. And so our best way to deal with that is to use randomness in the selection process. There are a couple of things I want to point out here that are worth noting. First of all, you will note that my randomly selected average was 2.8, so that fell about right there. That was not a particularly good sample, but just because it's significantly higher or lower than the true average for all 100 rectangles, it doesn't mean that my method was biased. Bias refers to, after repeatedly sampling, you consistently overestimate or underestimate the population value that we're trying to estimate with our sample statistic. And one last thing that I want to point out is that just by randomly selecting subjects to be in our sample, while that helps eliminate bias, there are other types of bias that can creep in if we're not careful. So let's go back and answer that question that I posed at the beginning of the video. And that was question number 1 up here. And let me get to that. So you may hear results from polls or other statistical studies reported in the media with emphasis that the samples were randomly selected. Discuss the following 2 questions in your group. Why do you think there's an emphasis on random selection? Well, hopefully at this point, you know why there's an emphasis on random selection. Random selection is a necessary component of selecting an unbiased sample, a sample that is representative of the population, or a process that leads to samples that are representative of the population. The second part is, what do you think could be the problem with allowing a good statistician to choose respondents for a survey as opposed to randomly selecting the respondents? Well, if we can't, without bias, select rectangles that are representative of the population, then how can we expect to select subjects for a survey that are representative of the population? So again, to help eliminate bias, one of the necessary components is to use randomness in the selection of the subjects.